I'm so excited you're able to join us for our African Digital Indaba. The Indaba is an occasional DH webinar on African cultural forms and heritage. And it's usually in addition to the annual African DH Symposium we hold in the fall. So please watch out for the next African DH Symposium later this year. My work is basically to welcome you and to thank Brian Rosenblum and Kellen, Dave from the IDRH, the KU Institute for Digital Research and Humanities, and then thank my colleagues in the Department of African and African American Studies, and of course, Glenn from the Kansas African Studies Center, our director, as well as every other person there who worked very hard to put this event together. Moderator for today's event is ATLI from the University of Toronto, who is an invaluable member of our community. So I'll just pass things over to Titi to moderate things, welcome people and lead us. Thanks, Titi.
You're welcome. Well, good morning, good afternoon, good evening, good day to you all, wherever you may be connecting with us today. As James already noted, my name is Titi Ayebusi, and I will be your moderator for this event. I am a PhD student in the English department at the University of Toronto, where I study Black Canadian literature, specifically Black women's life writing. Well, I want to heartily welcome you all to today's session of the African Digital Indabas. As James already noted, the African DH Indabas are an avenue for occasional African DH discussions in which mostly African digital humanist scholars are in conversations, African digital humanities scholars are in conversation with each other or with colleagues from other parts of the world. So whether you are a traditional intellectual or you are an organic one, as long as you're interested in African digital humanities, this is the place for you. So welcome again. Our core interest in gathering here today is in generating meaningful ideas that shape and move DH in Africa forward. We have two speakers who will be speaking on the topic Yorùbá natural language processing and machine learning. I would like you all, as you listen to me, to please write your location in the chat box. It will really be nice to know where we're all connecting from today. And if there are institutions that you are affiliated to, would appreciate if you can include these into your introduction as well. Just your name and where you're joining us from. That would be great. Before I go into today's talks, I would like to discuss some housekeeping with you. Each presenter will speak for approximately 15 minutes. If you have questions, I would implore you to please hold on to them until after the second speaker's presentation. After both speakers have given their talks, we will open the Q&A line. I would like to also mention that you are free to type your question in the chat box at any time. Otherwise, if you have questions after the talk is over, please feel free to raise your digital hand. You know that hand that is located at the bottom of your screen in the emojis section. Raise it. A raised hand indicates that you have a question for the speakers. And once it's your turn, you will be called upon to speak up. While you do, please remember to enable your mic while speaking. I would also like to ask us, please, to keep our mics muted, except when we're speaking for the duration of, keep it muted for the duration of this session. Otherwise, I look forward to an engaging session. And now to our presenters. I'm so excited to hear the talk of these two wonderful people who will be joining us today. Our first speaker is Ife Adebara. Ife is a PhD candidate in the Cognitive Systems program at the Department of Linguistics at the University of British Columbia. She is a member of the Deep Learning and Natural Language Processing Group, working under the supervision of Professor Abdul Majid. She's currently a PhD public scholar and an associate member of the African Languages Technology Initiative in Nigeria. For her dissertation, Ife is developing deep learning technologies of African languages and is engaged in working to make computers usable in African languages. Her most recent work, which will appear in ATLI in 2022, advocates for Afrocentric NLP for African languages. Ife, please, you have the floor. Take it away.
Please, can I go next? I'm trying to get my my presenter notes working, and I am a bit challenged doing that right now.
Absolutely.
So I think I'll need a few minutes. Yeah.
That's okay. Take
All right,
your time.
sorry. Yeah.
In that case, if David is ready to go, I will just talk to us briefly about what David does. So David Ifeoluwa Adelani, yes. David is a doctoral student in computer science at Saarlandes University, Saarbrücken, in Germany, and an active member of Masakhane NLP, a grassroots organization whose mission is to strengthen and spur LLP research in African languages for Africans and by Africans. David's current research focuses on NLP for African languages, multilingual representation learning, and privacy in NLP. David, are you ready to go?
Yes, I can.
The mic is yours then. Take the floor. Thank you.
Thank you for the invitation, Dr. Yetu, and everyone. And thank you for the introduction, Titilola. Yeah, sorry. Yeah, I believe you can see my screen now. So I will skip the introduction because we already did that. So the introduction to my talk is we're trying to connect to very different aspects: linguistics, which is focused on languages, and machine learning, which is focused on things like statistics, optimization, and algorithms. And in between, we have like natural language processing that tries to unify these two fields together, or tries to combine techniques from these two fields. So one thing we know is that machine learning research requires a lot of data. And but when you're talking about where the data will come from for natural language processing, we really need native speakers and linguists to create or generate this data. And the good thing is that what they generate are always high quality data because they are native speakers. Well, what we have seen, the current trend is that we try to bypass linguists and we try to generate noisy data and very noisy annotations, just scraping the web and doing some, using some algorithms to annotate data. And the effect of this is that we introduce a lot of bias to the data, also toxicity, and also a lot of things that are not supposed to be learned by the model are automatically learned. And now the trend now is how do we remove those things that are automatically learned that are not good. So the thing is that we need to work together, linguists, native speakers, and machine learning experts, to really advance NLP for African languages, and especially Yorùbá, because this is the focus of today's talk. So in this talk, I'm going to focus on like 3 aspects. First is addressing Yorùbá text quality issues in online resources using machine learning. The second aspect is leveraging a few thousand translations to build a good machine translation systems, at least in a specific domain. And the last one, if time permits, is distance supervision for named entity recognition, leveraging native speakers' knowledge. So for the first part, let me tell you about Yorùbá. Yorùbá is native to Nigeria and the Benin Republic, and it's also widely spoken in West Africa. It's the 3rd most spoken language in Africa. It uses the Latin script, but we also have diacritics on top of the words, and some letters also have some underdots. But what we notice on the web is that many of these underdots and diacritics are often are not represented. So when we talk about popular online resources for Yoruba that we can use, one of it is the Bible, which is parallel translation, contains like more than 30,000 sentences. We have JW300, which is also by religious text from Jehovah's Witness website, has over 450 parallel sentences. So these two data sets can be used for parallel translations. Another good source would be Wikipedia, which has around 100,000 sentences. But this is noisy because sometimes they do not follow the orthography of the language. And also Common Crawl has a lot of information, even sometimes it's large and very noisy, and sometimes it doesn't even represent Yoruba language. And they have a lot of things that, they have a lot of contents that are not language, and that could even, that are not even ethical. I don't know how to describe it, the noise in Common Crawl. So other sources will be news articles like BBC, Ashejiri, and other news articles in Nigeria that you might be familiar with. Okay, another source would be books and blogs. Some of them are noisy, some of them are clean, depending on who created them. So, but the first one is that I want to talk about what is the noise in this data. When we try to do things automatically to crawl articles from the web, whether they are written properly or not, we have this problem. They do not follow the orthography of the language. So this is the diacritics problem. And this problem is very simple. You have a single word that, depending on the diacritics on top, actually means different things. So we have something like owo, 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 depending on whether you have do, re, mi, or you have the underdot o or o, you have different interpretation of this word. And if you map everything to OWO, which doesn't mean anything in Yoruba language, there's a lot of ambiguities. And actually the effect is more critical in even technologies like speech recognition. So on Twitter, one of these days, we were talking about the problem of automatic, we're talking about this diacritic problem. And you have a word like, let's call it alejo for now, and can mean a lot of things. It can mean visitor, able dancer, snake chaser, snake owner, and a lot of things. So it's a really big problem if we train models that are not properly diacritized. So one of the quick way of where we can benefit from machine learning is to train a sequence-to-sequence model, where we give it a sequence of words with their diacritics, and it's going to output sequence of words with diacritics. And this method works pretty well, and it's very simple. And I think any grad student in NLP can easily implement this. And we find that you can use this to improve the quality of text that you can use to train models for your language. So in that paper, what we did is that we trained on this corpus. It's around, most of it, I think everything is not more than 500,000 sentences. And we evaluated on out of domain sentence, which is in the news domain, crawled from Global Voices. And we found out that even though we have trained this diacritics model on religious text and other books, we are able to do very well on out of domain sentences. And what we found out that we can even get a blue score of close to 60%. So blue score ranges from 0 to 100. So the higher, the better. So we are able to do around 60%. And there are even some newer techniques to improve the performance to be even close to 80% or more. So this is an example. The baseline approach is actually one of the problems with the baseline approach is that it introduces new words when it's trying to predict the diacritics. But with this method, most of the time we do not introduce new words, and we're able to get the right prediction. For example, here we have built in we can actually get the right diacritics on top. And this is one application of using machine learning to improve the text quality of Yoruba words. And this can be very useful for journalists writing text and for translators and many applications of this. So the second one is that now I'm jumping to machine translation, how we could benefit from what has been done by linguists or translators to build a machine translation system. Okay, so one of the major issues of building a machine translation system for English to Yoruba or Yoruba to English is because we do not have evaluation data set. And without evaluation data set, we are not able to know if we are developing, we're improving in the development of a good machine translation system. So, but recently we have this Forest 101 that I tried to develop evaluation data set for over 100 languages. So I'm happy Ife is here because in a paper, one of the things you pointed out is that there are some translations that are incorrect, even in what Flores 101 did. But we paid more attention to this because we are native speakers of this language. And we created this menu 20K, which has 20,000 parallel sentences, and it covers multi-domain parallel corpus. We also provide several neural NT benchmarks on this data set. Okay, so this is the data set we created, and it's from different domains. We have around 10,000 from the news domain, 10,000 parallel sentences. We also have something from TED Talks, which is from speech. And also we have something from book or digital domain, proverbs, and some other domains. So the idea is that we want to be able to build a machine translation system that works with several domains. But the problem is that we have very few number of sentences. If you are a machine translation person, you say, this is not possible. How can you build a machine translation system with 20,000 sentences? You really need like 1 million parallel sentences also. So we want to see how we can leverage the data set we have in the religious domain and try to adapt it to other domains of interest. So for that, we try to combine all the data set we have, Bible, JW300 that are in the religious domain, we combine it to this multi-domain Mayo 20K. And another thing is that we also did some transfer learning, or basically we train a model using the transform architecture of JW300 and the Bible, and we now fine-tune on Mayo 20K. And this is our result. One thing you can easily observe here is that the more data you have, the better the performance. So if you turn on the Bible, you have a blue score of 2. Like I said previously, the blue score ranges from 0 to 100. And this is just a way to measure the quality of the translation. And it's very low. But if we actually add more data from JW300, we can improve the performance significantly by 5%. And if we combine JW300 and Bible, we can even improve more. And with some transfer learning, just train on JW300 and the Bible and fine-tune on Mayo 20K, we can even reach up to 12.34. So, and if you have a blue score of around 10, at least for Yoruba, you're able to see something interesting. I mean, the translation starts to make sense from a blue score of even 8 or 10. Okay, and the interesting thing is that we even did better than Google Translate, at least in the English Yoruba direction. For the Yoruba to English, Google Translate was much better, but it's also nice to report where our models are not doing fine. Okay, and this is the result of multiple domains. And what you can see is that even on very difficult domain like Proverbs, we can reach a blue score of at least 9. And our model kind of works very well on several domains. This was quite impressive that just having 20,000 multi-domain corpus, we can adapt our model to several settings. Okay, so one thing we have just discovered in a new paper at NACO is that we do not really need up to 20,000 sentences if you're focusing on a single domain. And another interesting thing is that you also do not need other background corpus like religious domain. You can just have like 5,000 sentences in your domain of interest that are parallel sentences, and you can leverage pre-trained language models to create a good machine translation system. And the summary of this figure I have, which shows the number of sentences on the x-axis and the blue score, it shows that the baseline model is this fainted line for the transformer, which requires training on large parallel sentences, for example, in the religious domain. What we have shown is that using pre-trained language models, which is the recent models that have been used, is that just training on up to 2,500 sentences, you can already do better than this transformer models I showed you in the last slide. And with 5,000 sentences, you can even create a good machine translation system. So this creates a very good opportunity for us that if we're interested in the domain of interest, maybe COVID translation or proverb translation or else domain, we can just create a very small parallel sentences. We can leverage the knowledge of translators and linguists, and we can create a very powerful system. So with two examples, I've showed you how we can learn a lot from linguists and combine it with machine learning and create a very useful system, both in improving quality of online text and also machine translation. I'm not sure if I still have time, I can show you another example, but if not, I think it's already good to stop here. Do I still have time?
Well, it depends on how much you still need to cover. You can still take a couple of minutes if you need to.
Okay, yeah, I can do
just a couple of minutes.
Yeah, in 3 minutes. Okay, the last one is on distance supervision for named entity recognition. So in named entity recognition, the task is that we want to identify things like personal names, location, organization, or date, like you can see on the right-hand side. And on our resource languages like English, we can quickly reach a performance of 90, but on African languages as well, it's much lower. And here we could leverage linguistic knowledge and rules by native speakers to improve the performance, even without training any machine translations, any machine learning system. So what we have in practice is that we always have clean, manually annotated sentences, but they're always very small. And let's assume we want to perform named entity recognition in the news domain. We have a large monolingual text in the news domain, but they are not annotated. So what we can do is that we can use some external knowledge or resources like Wikipedia or Wikidata, and also we can use some native speaker rules that have been written by domain experts to do automatic annotation. So this is an example of date. So in Yorùbá, what we notice is that there's some keyword that precede the date information in Yorùbá. For example, ní ọjọ́ kẹrin oṣù Èrèlé, Global Voices by Fernando Gomez. Then you have the keyword ọjọ́ and oṣù preceding the months and the day. So one thing you can do is that you can quickly write a rule that shows you that once you have a keyword ọjọ́, then the next one is most likely going to be a date. And with this, you can do automatic annotation. And this is one way we can leverage domain expert, or a native speaker of the language. And another thing is that we can also leverage resources like entity lists from Wikipedia or phone books and do automatic annotation. Of course, sometimes it doesn't work. Maybe Global Voices is not in our vocabulary, but we can now combine that with machine learning to improve the performance. This is an example of what we're able to do automatically without any machine learning model. So we're able to achieve 41%. Of course, for some entity, maybe like organization is very difficult because the span is usually longer, but it shows that even just leveraging native speaker knowledge, we can create very powerful system. And of course, if we combine it with deep learning models or machine learning, we can even improve the performance. But most of the improvements in performance, which is the claim plus distance, is coming from the linguistic knowledge or native speakers writing rules. So I've showed you like 3 ways where you can leverage native speakers, knowledge, linguists, and also combine it with machine learning to create very powerful systems in different applications. Thank you. Yeah.
Wow, thank you so much, David. This has been such an enlightening and insightful conversation presentation. Thank you so much for sharing your knowledge with us. If you do have questions, I would implore you to hold on to them till after Ife's talk, or you can type them in the chat box where I will read them out when we get to the question and answer session. And now I will turn to Ife. I hope you're ready to go now. Ife, are you there?
Yes, I'm here.
Oh.
Can you hear me?
Yes, I can hear you now. Perfect.
Okay.
Well, take the floor.
Okay, so I will share my screen. Yeah, so good morning, good afternoon, good evening to everyone. Thank you all for having me today. And thank you to Dr. James Yeko for inviting me. And I would also like to recognize, I saw a couple people in the participant page. I saw Professor Puli Blanc is a renowned phonologist in Department of Linguistics at UBC. And I also saw Dr. Tunde Adebola. I got into NLP through him many years ago, right from my undergrad. I first got introduced to NLP through him. Yeah, so today I'll be talking about machine translation, and it's a topic I'm really excited about, and something I've been working on for quite a while. And at the end of this presentation, you will learn how the complete pipeline for building a Yoruba machine translation system. And in this slide, you would see a, so I'm using two screens actually because I have a little issue with this computer, but you'll bear with me a bit. So like I said, on this screen, you will see that there's a map showing Yoruba and the dialects that are spoken across Togo, Benin Republic, and Nigeria. So Yoruba is one of the major languages in Nigeria, and it's like David said, it's widely spoken, particularly in Nigeria, in some of Togo, in some of Benin Republic. And in this presentation, I would first start by explaining what a good translation looks like. I will give some examples from Yoruba, and then I'll explain briefly methodology for building a machine translation system. And then I would share some results and give insight on what those results mean for where we have to go from here. So a good translation system, I would say, is one that fulfills the same purpose in a new language as the original did in the language in which it was written. So let me unpack that a bit. It means that a good translation should convey similar information, similar meaning, and similar emotion from the source language into the target language. So for instance, if I say in English, the boy kicked the bucket, figuratively, which means the boy died, what I want to have as a Yoruba translation is a figurative interpretation of the boy died as well. I don't just want to say the boy died in Yoruba, but I want to say, give it figuratively as well. And then also when I talk about conveying the same emotion, it means that if the source text is funny, for instance, I want to have a funny translation in Yoruba as well. And it's important for me to also mention here that I italicized similar because a good translation is an approximation. And the goal in translation really is to select the closest interpretation to the source language, from several available options in the target language. So this means that there are usually more than one translation available for a source sentence, but we want to choose the one that best captures the information, the meaning, and the emotion. So in order to be able to do this, then therefore, we want to be able to have a translation model that has general knowledge about the worlds of the source and the target language. So when I talk about general knowledge, that is also what we refer to as common sense information. Like a normal human being knows, certain things about, the culture, the beliefs of a people that would influence how they translate. And we also need to have linguistic information of the source and the target language. And by linguistic information, I'm talking about the syntax, the semantics of the language, the morphology, the stylistics, the pragmatics. All these are key elements in a good translation model. And then we also want a model that is able to reason. And reasoning is really important because you need to make a best choice from a set of options. And if a model can't reason, then it's not able to, to make any good decisions. And reasoning plays a particularly important role when you have concept gaps. Concept gaps are situations where a word or a concept in the source language is missing in the target language. So in those types of scenarios, reasoning plays a very crucial role for a translation system. So I'm going to give an example that will drive this home a bit more. So in the first rectangle, I use an example from the Bible that says, a scripture in the Bible that says, Jesus is the bread of life. And when this statement is translated into the Yoruba Bible, what we see is Jesus is the food of life. And now the reason for making such a choice is because bread is not a staple food for Yoruba people, but bread is a staple food for Mediterranean people, English people. So if you use the word Jesus is the bread of life in Yoruba, it's not going to capture the meaning that the source text is trying to capture, which is that Jesus is what you need all the time. Yoruba people don't need bread all the time. It's not food that is eaten so often, right? So in that scenario, the translation that is preferred is Jesus is the food of life, even though there is a word for bread in Yoruba. So this is an example of the ways, translation, the kinds of decisions that human translators make when doing any form of translation. And then in the second rectangle, where you'd see two Yoruba sentences, the first one says Babara issue, and the second one says Baba Feron issue. But you will find that the translation for issue, which is yam, varies based on the context of the verb in which it occurs. So in the context of eventive verbs, a noun, a bare noun in Yoruba can have up to 4 different translations. And the preferred translation will be based on the context in which the word has occurred. And in the context of a stative verb, a bare noun can have a generic interpretation. So from these types of examples, we want to be able to have a model that can think critically and make a best choice from the several options that are available. So how then do we build a machine translation system for Yoruba? to build one, we need large amounts of good quality data. Now, remember that I said that we want to be able to capture information, we want to capture meaning, we want to capture linguistic content, right? So we need good quality data that captures linguistic information. So a good quality data will have information about the syntactic structure, the semantic information. It will show us the morphology of the language, and then we can also learn some contextual information from such a data. Now, I have highlighted good quality. David also spoke on this, because no matter how good your model is, if your data is bad, it definitely would affect the output of your model. It's like garbage in, garbage out. So, and a lot of machine translation models, and not just machine translation models, NLP models are reused, fine-tuned on other data sets to build new models. And if the original model is built on faulty data or poor quality data, then that poor quality information also, is passed on to models that are built on top of that model. Then next, we need a computational model. Now, we need a computational model that is able to reason. And usually reasoning in computer science is usually by probabilities. So you are able to have a model that is able to select the most probable translation from a list of options using probability calculations. And then a computational model that can also learn contextual information, so that is able to read through the entire data set and build a probability of having each word in a certain context. And next, we need an evaluation criteria to determine the model's capabilities. And the model's capabilities here is how well the model is learning, what is the model learning, how can we improve the model. All this is important, and the evaluation criteria is what we use to capture this information. Now I go to a concrete example where I build a simple machine translation system for Yoruba to English. And for the Yoruba translation, I use the Yoruba Bible, which is a good quality data set. I pointed out earlier some of the translation decisions in the Yoruba Bible, which makes it a good quality one. And then I also use an English NIV translation. And for machine translation, you usually need parallel data. That is data that is equivalent in both the source and the target, although there are scenarios where you might not have parallel data, but still be able to do some translation. And so we have the Yoruba Bible and the English Bible that has similar number of verses, although the words and the tokens differ. And then I go on to preprocess the data, and preprocessing involves aligning the data to ensure that the source examples and the target examples are coming equivalently at the same time. So when you have a source example, you're able to have an equivalent target translation, so that the system is able to learn those in a parallel fashion. Next, I tokenize, which is breaking down the text into individual words, and then I convert every individual word to lowercase letters. It is important for me to say here that converting to lowercase letters is not always necessary, and I just made this decision because the Bible is quite small, and I wanted to have everything on lowercase letters. So the next thing is a state-of-the-art model, which is the best model for building machine translation and most NLP and also for most NLP tasks. And it works by using self-attention to differentially weigh the significance of each part of the input data, so that this way each string or each word in a sentence will have various weights and probabilities. So like I said previously, for a computing model to be able to think, it needs some level of probabilities. So this model, I can't go into detail of each of the components right now. I'm just going a bit eye level on describing what this model does. So what it does is it takes in the input sentences and it tries to learn a good weight, which is the probability of having maybe akpa followed by essay, or A followed by boy, or D followed by book. So it wants to know, where is it possible to have book and D followed by book, or is it possible to have book followed by D, right? So it uses probabilities to determine the next target word, given the target words that have been seen so far and the source sentence. And then next, I use an evaluation criteria called the blue score. The blue score is the most used evaluation metric for machine translation, and it compares the n-grams of the candidate's translation with the n-grams of the reference translation, and then it counts the number of matches. The closer a machine translation is to a professional human translation, the better it is. So if you look at the example below, the parts that are highlighted in red are the parts that deviates from the reference translation. But if you read the output of the transformer model, you find that some of the choices are okay, they're not wrong. So for instance, when it says, I will show them my wonders, this says, I will show him how much wonderful things. So using wonderful instead of wonders would not be penalized by a human, but the computer is penalizing differences between the reference translation and the translation from the transformer, even when you have correct synonyms. And as a result, a human translation of the output is necessary to further evaluate the model. So I do I do a human evaluation, which is a human being looking through the output of the model and the goal data and seeing how they vary. Now, because this is a simple model, and this is just without any intervention, no transfer learning is used here, no pre-trained models are used at all. So this has a low blue score of 37.93. But if you look at the examples to the right, you would see that the output from the transformer is quite reasonable, although this is not the best that can, that we can have from a machine translation system. And we can also see that the transformer model is showing signs of reasoning, because it's not just copying the data from the tests, or it's not just learning and just copying from the source to the target, or from the training examples into the target. We can see it's making reasonable decisions on what word to use in which context. Now, although this is not the best translation we can see, but we can see a sense of reasoning going on here. So looking at a fine-grained analysis of the output of the model, what I was able to find is that the Yorùbá bare nouns are always well translated 81.55% of the time if they translate into a definite singular than if they translate into something else. If you look at this data, the part highlighted with a red circle is showing 81.55. So that is the number of times the model correctly translates into a definite singular example. And if you look at the indefinite plural example, for instance, you'd see that it only is able to correctly translate into an indefinite singular 22.22 times. And what I find is that the difference in quality is dependent on how many occurrences of indefinite plural examples we have in the text itself. So we have many definite singular examples in the training text that we used, and fewer indefinite plural examples in the training text that we use. And because of this, the model is learning definite singular better than it's learning the indefinite plurals. So now this tells us something. It tells us that machine translation requires many examples for it to work well. So if we want it to work well in other scenarios, to work well in translating into indefinite plurals, into indefinite singulars, into definite singulars and definite plurals and generic examples, then we want to have good representation in the data set that we have. So we need more examples. And when we have more examples, then we have better probabilities because the model has seen several examples and is able to, seen many words and is able to make decisions on the best word in each context. Now, this also has shown us that we might need text from different domains because we're using the Bible. There's a lot of context information in there already. Perhaps we want to use other texts that do not have as much contextual information. Perhaps we want to add proverbs where you just have a short text and the interpretation, and there's little context to why you have that text. And so all these types of, these findings show that you might need more than one domain to be able to capture certain concepts in the language. And then we can also see that the blue score may erroneously penalize models, and we want to be able to think of a way of evaluating our models better, even with maybe using humans to look through the fluency of the data of the model output, to look through the grammatical correctness of the model output and things like that. So in conclusion, I would say that to improve machine translation for Yorùbá, we need to prioritize good quality data collection for Yorùbá. And this is a very crucial aspect. I believe Yorùbá shouldn't be a low resource language because Yorùbá is one of the most studied African languages linguistically. We have more than 40 million speakers. I would assume that if everybody was doing something to ensure that Yoruba data is available digitally, Yoruba would not be a low resource language. So I would say we need to prioritize good quality data collection for Yoruba. We need to prioritize developing models that learn concept gaps with few examples, and also prioritize evaluating different aspects of linguistic structure that a model learns. And I would also like to acknowledge the different organizations that have been funding my research. And I would say thank you. Eshegoni.
Well, thank you so much. Thank you so much, Ife. That was a little bit over, but
Okay. Sorry about that.
Yeah, it's okay. We enjoyed your conversation. We enjoyed your presentation. It's very enlightening, and it's nice to see how your work connects with that of David's. And we are now in the question and answer section. So please, if you do have questions, raise your hands, and then we will call you. I will be on the lookout for. Okay. So I'll have the gallery. Okay, perfect. So I did see Adebowale's hand go up first. So please, you have, if you unmute yourself, and you're free to put your camera on if you want, and then you can go ahead and speak up. Adebowale, please.
Yeah, hello.
Oh, yes, we can hear you now.
Yeah, okay, thank you very much, Ifeoluwa and David. And I think I'm very, very happy to be part of this webinar today. I'm actually not a natural language data scientist, so to say. I'm into computer vision, but I'm working on a project that is related to natural language. And a friend of mine that I spoke with shared me this link, and I'm happy to actually see not just that people are working on natural language from Nigeria, but they're actually working on my language, which is Yoruba. So I'm quite impressed. And I'm really excited with David's work and Ifeoluwa's work. I mean, you guys are really detailed. It's really detailed, especially the transformer that you used, Ifeoluwa. That's what I'm actually using I'm using self-attention for land cover classification. So when you're explaining, I could actually resonate with what you're saying. I'm really happy about that. So the question I have probably to Ife, which I think I would definitely reach out to you to have a call with you, or probably a session with you after this webinar, is that most of these corpus that you are using, are they also, because I don't actually see most of this stuff in production. I mean, we see a lot of high accuracy, okay, our model using this particular function and everything have this accuracy, but what about in production? Are these corpus, let me use that word because yes, I'm not really into natural language that much, but are these Yoruba corpus, are they available for development, like for production, not just in publication and research alone? Can we use it to actually probably develop a product? And two, the second question I have is, imagine if we have a particular saying, which is a mix of Yoruba and English. So I can probably, for example, let me just try to start an example. I'm speaking English, then I started a few Yoruba words, which is kind of common in music, in Nigerian music. They will keep on singing, then there will be some insertion of Yoruba words. Is there a way this can be done also in terms of separating the English, picking the Yoruba, translating it, and putting it back in the text of the English and getting meaning of what that lyrics is talking about? I would love to hear from you. Thank you.
Okay. Thank you for your question. I would say for the data sets, they can be used for production, and they are being used for production. A lot of machine translation models that you see, for instance, Google Translate use a lot of all these data sets to build their own models, although I believe they have more data than they actually bring out to the public. But these data sets definitely are part of the pipeline they use for building their own models. So yeah, they're very useful for building real tools. And also for the second question, you were talking about code mixing. There's a lot of research on code mixing, even though that's not my own area of research. There's several tools to do good translation, even in code mixed text. There's also David mentioned transfer learning. There are a lot of language models that can be used to get some information that would help the translation downstream. And you can also, I've also tested on, but not for Europe, I tested for Hausa to English, where I used a machine translation model for English into another language. And I find that it's able to learn representations of English, learn representations of Hausa, learn representation of other languages, and improve the translation downstream. So yeah, I would say very, very, that's an active area of research, and they're making progress on that. I would say, I don't know if David has anything to add to this.
I think you're muted, David.
Yeah, so I think the only thing I wanted to mention about using it for production is that one just to be careful about the license of the data, so that you don't get into trouble. Apart from that, yeah, it can be used.
All right.
Sorry, please, sorry, I don't understand what you mean by we should be careful about the use of their products. Sorry.
No, the license of the data.
Oh, okay, okay.
Yeah, so the copyright, for example, JW300 is large, but you cannot use it for commercial purpose. So, if you want to build a system for translation system, you cannot use JW300 for commercial purpose. And you can also not use all versions of the Bible. So you have to also pay attention to the license and copyright information.
Thank you very much for that. I wasn't expecting. I thought it would be open source. Thanks for mentioning that.
All right, thank you, Adebowale, and thank you to Ife and David for giving us such a useful response. I will take the next question, and that is from Baba Oladimiji. So please, if you can ask, thank you, and go ahead.
Hi, thank you, everyone. Fantastic presentation, David and Ife. I have some questions. So the first one is, David, the translation and NER models that you're talking about, are they text-based models or are they speech-based? And so just curious if you've considered speech-to-speech translation or speech-based NER, and if you have any thoughts on that. Then for Ife, the evaluation criteria, did you consider other ones apart from BLOW? I know BLOW is kind of like the standard one, but based on the problems you highlighted with BLOW, do you have any thoughts on potential directions that we can use, like other evaluation criteria that can result in higher accuracy? Then the last one is on data set availability, right? So things like Google Translate, they currently do a poor job of translating to like African languages, especially like Yorùbá. So the data set you guys are working on, any thoughts on how you are thinking on making it available so that more people building products can work on this? And by the way, my name is Baba Oladimiji, and I'm a founder of Amazetu, and we do like speech recognition. Sorry. We do speech recognition in African languages. So this is a very, very interesting and exciting talk. Thank you, guys.
Yeah, go ahead, David.
Yeah, thank you. So my answer is very short. I'm only working on the text side, no speech for now, but I think speech-to-speech translation it's a really important area of research. And we have very few works in African languages, so definitely should be a good extension. And for NER, it's also text-based. So yeah.
Okay. For the question on evaluation criteria, I mentioned that the BLOW score is not a very good metric. And so for that reason, I use human evaluation. So a human being looks through the data output and then is able to look for the particular concepts that we're translating for. Now here, this is particularly for checking how well the model is translating BA nouns in the different disambiguating environments. And a human being does that. And I would say that if we're going to have better evaluation metrics, then we want to particularly pay attention to the linguistic particulars of those languages and be able to build something for that language. Of course, I know that might be difficult to scale for many languages, but I would say right now, thinking through the whole machine translation problem, I realized that just having a blanket or a generic evaluation method might not work well on the long run. If we want to pay attention to the quality of the translation, we need to actually pay attention to the linguistic particulars of those languages, because those languages can be very different. Yeah.
Thank you. But what of the data set availability? Thoughts on that?
Yeah, so for data set availability, a lot of what I've been working on, I've made them publicly available. And I believe a lot more people are doing that too. I've seen a couple of papers that David has written. I believe Menyor 20K is available. There are a lot of other data sets that Masakhane has been building that is available publicly. I think a lot of people are working to get these data sets available to the public to improve machine translation and other NLP. Yeah.
Thank you so much. Thank you.
Oh, well, thank you so much for those who've asked questions. Unfortunately, we'd only be able to take 3 more questions because we're already running over time. I think we can run this up to 7. I think that should be 12:10, after which we will have to disperse. However, if you're ready, if you're willing to stay on and still engage, you're welcome to. In that case, I will go to, I think the first hand I saw raised is Kola Tumbosun. And just before you take it off, Kola, I'm a little bit confused. There's another David Adelani whose hand is up. Is that the same as you, or is that someone else, David?
That's not me.
That's not you. Oh, that's interesting that we have 2 David Adelanis. Okay. All right, then. So I will attend to the questions of those whose hands are already up. If we do have enough time to go through them, we will try. But if not, at some point, we'll have to end this session. So please, Kola Tumbosun, you can speak now. Thank you.
Thank you, everyone. I want to be short because I see the hand of Dr. Adebara is up, and I would like to hear his question as well. Mine is just a simple 2-part question. One is, how did you find yourself in NLP, NLP Nigerian languages? What drew you into this space, and what do you see as the future of this industry or this space for research, for different directions in the next 10 to 20 years? Thank you.
So if I say how I got into NLP, I studied linguistics for my undergrad, and right after finishing, I met Dr. Tunde Adebola, and he was working on I think SIL Flex at the time. He was reviewing the model at the time, and so I got to work with him on that. He was also working on the localization for Microsoft Vista, Windows, and I got into that space, and then I got really interested, and I'd say that's how I got into NLP. And since then, it's been mentoring me, and I would say that a direction for NLP for African languages, I see a very big future for this work. I believe that I believe NLP is actually going to change the language use even in Nigeria. A lot more people in Nigeria and in Africa will become proud of using their language with time. I believe there'll be more there'll be a lot of what's the word now, languages that are probably at the verge of extinction will probably do a little better because of their use in artificial intelligence. I believe more and more people are going to get involved in NLP, and I just feel with time it's going to change the whole system, as in the whole language use in Nigeria, in Africa. Yeah, that's what I would say. Within the next 5-10 years, we're going to see a lot of models springing up that we would never have thought could come up for African languages.
And David, if you want to respond to that as well quickly.
To be quick, so I got into NLP with this problem, automatic, this diacritics problem in Yorùbá. So that was what I was thinking about until I decided to just go full into this. I'm just considering how African languages in general are underrepresented in the research field. So that's how I got into NLP. And on the future, I think I want to see more research on speech of African languages, because we have more opportunities, because a lot of oral, a lot of information, we have a lot of data, just people speaking and passing information. Even though they cannot write, we can learn so much from what they're saying. I think another thing is that I want to see more people appreciate the language and also speak it, because I think people that can speak Yoruba fluently, the number is reducing. So if this talk was in Yoruba totally, it would be difficult for me to give a 30-minute talk without code mixing with English. And this is not what my parents would do. Maybe they'd be able to say even 2 hours of talk without coordinating. So I would like to see more people appreciate and speak in this language. Yeah. Thank you.
Your responses. I will go to Tunde Adebola now, and you have the mic, sir. Is Tunde Adebola there? Okay, so I can go to Orin Yusuf and then come back to Tunde when he's ready. Orin, are you there? All right, perfect. Thank you.
Yes, I am. Thank you. I have a question, or question and comment for Ife. I'm working on Hausa right now for my master's thesis for machine translation evaluation with cross-lingual representation, and I wanted to, maybe after this I can share some results or non-published findings that I found. That me and my supervisor have found pretty interesting results concerning specific domain correlation with human judgment for the previous WMT system findings. And I know it's not same language family as Yorùbá, but we found similar geographic languages have pretty substantial findings compared to the specific model that you're using and how much pre-training data and which domains that they come from. And I was wondering if you, because I remember in your presentation, you also did works with I think it was either you, yeah, either David, with proverbs and specific domains related to Yorùbá and how the language is best used. And I was wondering if you, what other metrics you've used and did statistical results for correlations with like system level human judgment and what your findings were.
I think David was one who spoke on using different domains, data from different domains. So I don't know if you want to talk on that.
Yeah, though I think you're asking on metrics generally, right? So it's still a area of research because Blue doesn't seem to work very well for African languages. I mean, you could try this CHRF, which probably works better for morphologically rich languages. So, we have tried it for Yorùbá. I don't see a big difference apart from that it correlates better. But this thing needs more research, and I don't have a better alternative. But for Hausa, I think you can still have a good idea of the performance with Blue. Yeah, I'm not sure CHRF will give you something there. So, but still, I mean, metric is a big discussion in the community, so there's no right single answer on how to go about this.
Yeah, I was, oh, sorry.
Yeah, I just wanted to say that you might also want to try determining specific concepts in Hausa that you're interested in knowing how well the model is working, and look for human evaluators who are probably native speakers or linguists that are researching on Hausa. And sometimes you might not know exactly what concepts to look out for. I would say you might want to reach out to maybe a linguist working on that area, and they would be able to give you interesting concepts to particularly test for, because you can't just test everything in the language, in the grammar of the language, if you're using human evaluators.
Thank you. And also, David, we were using a BERT score, and we found that it worked. There was a higher correlation with than Blue score for a lot of these, I think Hausa and Swahili. Okay. But thank you.
Yeah, I think the correlation between Hausa and Swahili would have a lot to do with Arabic. A lot of Arabic words have been transferred into Swahili and also Hausa, so there'll be a lot of correlations because of a language that they both borrow a lot of words from.
Oh yeah, I meant the correlation with the system. So like with the human evaluation, I was just using not between Hausa and Swahili, but Hausa and English.
Oh, okay.
All right, thank you guys. I don't know if Tunde Adebola is still there. If he is, we'll be happy to take his question now. Okay, I can see. All right.
I'm here.
Please go ahead.
Thank you.
Sorry, sir.
Sorry, I was let down by my connection. It's not really a question. I just want to make a few comments. It's really gratifying to be in this gathering today. I've dreamt about a day like this since the mid-80s, and it's really, really interesting to find really high quality work going on in NLP for Nigerian and African languages, particularly Yorùbá. I'm particularly intrigued. I mean, I know Ife's work very well, but I'm intrigued by David's recourse to rules, because there's this tendency to run away from rules. Everybody thinks data it is. And I say this all the time. Data-driven approach is children's approach. Rule-based approach is expert approach. When I decided to learn French at age 50, what I was taught was rules. But when I learned Yorùbá, when I was a child, I was just immersed in data. So there is still a place for rules, and I'd like to continue to encourage David to not to be moved with the flood of data-driven, important approach, but complementing data-driven approach with rules acquired automatically, I think is the future of machine learning. As for availability of data, we need to look at this very, very seriously. And the main problem with data in many of our languages is that our languages are not used in domains in which they leave footprints. The way to really get data is not sitting down and collecting data and because it's just too expensive. The way that you can get big data, the kind of data that can really give you good results, is to arrange to use the language, encourage people to use the language in domains in which the use will leave footprints. There'll be recordings, there'll be the documentation, there'll be data. And so I just like to encourage two speakers, very good presentations, and encourage many others to join in and help to improve the status of our languages. Ife's presentation, what Ife said recently really encouraged me that it is in the use of these languages, when our languages find their ways into technology, they give a lot more of status to the language, and people take the language a lot more seriously. Each time I've been to secondary schools and demonstrated the Yorùbá speech recognizer or speech synthesizer, there's so much pride in the young people. They look at the language in a new light. So this is the way forward, and I congratulate everybody that's been involved in this. Thank you very much.
Thank you so much, sir. That is just a fitting wrap to this question and answer session. I will hand over the mic now to James Yeko. I am sorry, I don't think we'll be able to take any more questions, given that we have gone significantly over our time limit. And this has been a splendid experience. It has been beautiful to listen to your work as in a natural language. I will call myself an enthusiast. I find this session very, very enlightening. And it's nice to see the work that goes behind the Yoruba language curation and its entry into technology. Thank you so much, David and Ife. You have done a beautiful work, and I hope to see your work out there in the future. And I will hand it over now to James Yeko.
Thank you so very much, Titi. And thanks again, Ife and David, for these amazing talks. I have learned a lot myself. I was also gratified to see Dr. Adebola and Oga Kolatuboso in the audience. A number of other scholars are in the audience. Thanks for joining us, Professor Polly Blank and Professor Dutola. Thanks for being here. We'll have the recording for the talk on the African Digital Humanities website here at KU. So please be on the lookout for that. We'll also post this on our social media platforms, our various social media platforms. Please look out for our African Digital Humanities Symposium in the fall. We should continue this kind of conversation or some kind of iteration of it in some way later in the fall. It's been a great talk. It's been a great time. I appreciate everybody for helping us put the talk together. Thank you, Brian, and thank you everybody at CAST. So on this note, we'll just call it a day, and thank you everyone for coming.
I would like to put in a quick word there that Ife and David Eshigon Amatunri. For those who are not speakers of Yoruba language, what I just said is thank you so much, and we hope to connect with you in the future. Bye for now, everyone.
Bye.
Thank you.
Thank you.